Welcome to lesson 98.
It is the very first lesson of a new unit on scientific notation. In this lesson, watch as I model these 3 criteria for success: that I can accurately represent numbers using scientific notation, that when I'm given 2 numbers written in scientific notation, I can determine how many times larger or smaller. The other one is using magnitudes of 10. In other words, using those exponents, I can tell how much bigger or smaller, how many times bigger or smaller the one expression is versus the other. And finally, I can accurately represent numbers from scientific notation in standard form and vice versa. So I want to be able to fluently move back and forth. In our very last unit, we're going to talk about extreme numbers, numbers that are extremely large or extremely small. And these numbers are often written in scientific notation. This is a way for us to actually do calculations with numbers that have multiple digits in them. Okay, so if I'm thinking about things like the distance between planets or universes, I might use scientific notation for those extreme large numbers. If I'm looking at the size of molecules, even parts of molecules, then I might go to scientific notation because they are extremely small. Let's look at 2 different types of numbers. For example, I'm going to write this one as 8 times 10 to the 12th power. So the first thing I want you to notice is that scientific notation is written in a format that looks like this. C, which is some number, and C has to be greater than or equal to 1, but less than 10. Most of the time we'll recognize that it's 1 digit in front of a decimal. That's my cheat for it, as long as there's 1 digit in front of a decimal. So if I had 18 times 10 to the 12th power, it wouldn't count. That is not scientific notation because I have 2 numbers in front. So it has to be greater than 1, but less than 10. If I had 0.81 times 10 to the 2nd power, also wouldn't count because I need 1 digit, just 1, in front of that decimal. So that's the first thing. The second thing you'll notice is that it is always times 10 to some power. You're constantly going to see that. So 10 is always the base, and your exponent must be an integer. That means it can be positive or negative. We can use either one. If our integer is 0, then we know the entire answer is just 1. So it would just be 8 times 1. And oftentimes we just don't use any digit for that. Other things to note is that this part over here, this exponent tells me if it's a large number or a small number. So 8 times 10 to the 12th tells me that this is a very, very large number. How so? Because this means if I were to multiply 10 to the 12th power, think about this, math marbles. I would have 10. Is this 10 to the 1st power, to the 2nd power, to the 3rd, to the 4th, to the 5th, to the 6th, to the 7th, to the 8th, to the 9th. I'm even out of space and I'm only up to 10 to the 9th. That is how many times you're multiplying that letter C, that 8. So it's a very, very, very large number. And if it's negative, then I know it is a much smaller number. And we're going to talk about how to move back and forth between scientific notation and just a standard number. The distance from Earth to the Sun is about 93 million miles. Express this number in scientific notation. So let's look at this number. And I want to think, ideally, where would you want the decimal? Remember, C times 10 to the n. This number, this C, must have 1 digit before the decimal. Remember, it can be greater than or equal to 1, but it has to be less than 10. So ideally, just by looking at it, I know I want my decimal to be here, between the 9 and the 3. That way, this number is still less than 10, but it's more than 1. So let's write this down. So I would have 9 3/10 times 10. Let's figure out what the n would be. What I'm going to do is I'm going to count how many decimal shifts it would take. I would have to move it 1, 2, 3, 4, 5, 6, 7 times. So this is 9 3/10 times 10 to the 7th power. That's how I rewrite it. Hit pause and jot this down into your notes. The volume of Jupiter is about, wow, this is such a large number, I'm not actually sure how to say it. Let's see, it's in the millions, billions, trillions, so it's bigger than a trillion. That's how large this number is. What is the volume of Jupiter written in scientific notation? All right, so I'm going to do the same thing. I'm going to write down my number. And the first question we're going to ask ourselves, where ideally would you want to put that decimal so that the number in front, the first digit, is in front of the decimal? So oftentimes this just means look at your front number. Just look there and you want that decimal right behind it. So I want 1.43128. I'm not going to write all the zeros because it doesn't change the value. And I want this times 10 to what number? Let's figure out what our n is going to be. Again, all I'm going to do is figure out how many decimal spaces will I have to move to get from here to here. So it's a count. Now, I could count one at a time, but I also notice a lot of periods here. So for example, the ones period, the thousands. So I already know this is 3 jumps. Let me put it over here. 3 jumps, 6 jumps, 9 jumps, 12 jumps, 15 jumps. So this would be 1.43128 times 10 to the 15th power. So looking at my answer choices, I already know that these two aren't big enough because they are 10 to the 10th power. So now I have 2 choices, and looking at these two, which ones can I eliminate? Obviously, I can eliminate C because it is not in scientific notation. This part over here, it should be 1 and 431. There should be a decimal point right here. So that leaves me with my final choice, D, which does match our work. Hit pause and jot this down. Okay, Math Marbles, before you get into your practice, again, biggest takeaway, I want that decimal after, if it's a very large number, after that first digit. If you see a number that has a bunch of zeros, something like this, then I want to find that first digit, that first number over here that's bigger than 1, and I want that decimal to be right behind that. And that's that same shift. I'm going to figure out how many spaces that would be. 1, 2, 3, 4, 5, 6. So this would be 8.36 times 10 to the -6 because this is a very small number. You're going to get a lot of practice in, and being that is your first lesson, get feedback from other individuals to check to make sure that you are getting accurate answers and that you're not making small mistakes, which are just very natural in the beginning of learning. That's it for today, Math Marbles. I'll see you in the next one. Be well.